All right, let's take a look at this example from our test. This is number 4, where we're trying to find the inverse of this domain-restricted function. So we have here that f of x is equal to 1 over x squared minus 6x plus 9, where x is strictly greater than 3, okay? So we need this domain restriction here to find our inverse because this guy is not a one-to-one function. The first thing I want to do is just think about the function without the domain restriction. So f of x is equal to, I'm going to go 1 over, this is a trinomial that is going to be what we call a perfect square trinomial, so it can be factored into a binomial squared. This would be x minus 3 quantity squared, okay? So right now, if I look at this function, again, forget about this domain restriction. The domain restriction that comes with this guy is going to be that x is not allowed to be 3, right? So the set of all x such that x is not allowed to be 3, because if you plugged in a 3 there, 3 minus 3 is 0, 0 squared is 0, and 1 over 0 is undefined. If we looked at the graph of this guy, you can see it is not a one-to-one function, okay? And also, if you look at where the x value is 3, you'll see that this guy is going to be undefined, okay? Now let me write this out here. So we have f of x is equal to 1 over, we have this quantity x minus 3, that's going to be squared. Okay, so here, let me actually list that the domain is going to be the set of all x such that x is not allowed to be 3. So let me list that. Okay, so additionally, we see that this guy is not a one-to-one function. If we make these horizontal lines here, okay, they're going to impact the graph in more than one location. So the way we're going to get around that is we're going to take a piece of this guy, okay? So we're going to restrict the domain to say, hey, anything that's greater than 3. So what I actually want to do is just take this piece of the graph right here, okay? And basically I'll have the same range, but a restricted domain. So this is going to be our graph that we're going to work with. So now this would be f of x is equal to 1 over that quantity x minus 3, okay, that's being squared. And here specifically, I'm saying that x is going to be strictly greater than 3. Okay, so that's this graph right here. So now this guy is one-to-one, and so we can find an inverse, okay? Now, a couple of things here. You might want to write down that the range is going to be that y is going to be greater than 0. Okay, so you can see that graphically it's going to approach a y value of 0 but never touch it. Or you can also get this from inspecting the function and thinking about it. As I plug in values, kind of going this way for x, getting closer and closer to 3, this guy's going to blow up, right? It's going to take off like a rocket ship because I'm going to end up dividing by something that's really, really small. So let's say I put something like 3.0000001 in there, or it could keep getting smaller, keep getting closer and closer to 3 without actually touching it, okay? And what's going to happen is I'm going to have 1 divided by a really, really small number, and so that's going to approach infinity. Okay. The other way, if I put really, really large numbers in here, let's say I take like a billion or a trillion or whatever it is, I subtract away 3 and I square it, 1 divided by that really, really large number is going to approach 0, okay, but it's never going to actually touch it. Okay, so this is our domain, x is greater than 3, our range is y is greater than 0, and we can see that this guy is going to be one-to-one. Now, when you find the inverse of a function, remember you're going to switch the x and the y's out. So a point that is like 4, 1, so this guy right here, which is 4, 1, is going to end up on the inverse being 1, 4, right? So 1, 4. So that's going to be on the inverse. So let's go back and let's just write this out. So we have f of x is equal to, I'm going to have 1 over my x minus 3, quantity squared. And I'm going to say here that x is going to be strictly greater than 3. And I'm just going to also write here that y is greater than 0, okay? So what I'm going to do is I'm going to replace f of x with y. So let me just swap that out. And then I'm going to swap x and y, okay? So I'm going to say that x is equal to 1 over, you have this quantity y minus 3, okay, that's being squared. And I'm going to switch these around because the domain becomes the range and the range becomes the domain because we switched x and y around. So I'm going to say now that y is greater than 3, and I'm going to say that x is greater than 0. Okay, so this is what we're working with here. Now, the idea here is that I want to solve this guy for y, and then I want to use my f inverse notation. So the quickest way to do this, I'm just going to raise both sides to the power of -1. And so this would give me that, and I'm going to actually switch these around. This would be 1 to the power of -1, which is just 1, over, you'd have y minus 3, this is your base here, raised to the power of 2, which is then raised to the power of -1. So all this is going to do is make the exponent down here negative, okay? When I drag this across the fraction bar, this is going to become positive. So I can write this as y minus 3, this quantity being squared, is equal to this guy right here. Basically, I'm going to drag this across the fraction bar and say this is 1 over x, okay? So this exponent here just becomes positive down here, again, because I'm just dragging it across the fraction bar. Okay, so to solve this for y now, let me kind of move this down. I'm just going to take the square root of each side. So I'm going to take the square root of this side, and let me move this down so I have some room. And then I'm going to go plus or minus the square root of this side. Now, you're not actually going to need the minus here, and I'll explain why in a moment. So keep in mind we have this guy right here. Okay, we're going to come back to that in a second. So let me scroll down a little bit. And I'm just going to say, okay, well, this is going to cancel with this. So I have y minus 3 is equal to, let me put plus or minus, my square root of 1 over x. Now, let me just simplify and clean up a little bit. I'm going to keep the plus or minus for now. I can split this up into the square root of 1, okay, the square root of 1 over the square root of x. So what I can say is that the square root of 1 is 1. So let me rewrite this. And I'm going to say that I have plus or minus 1 for right now over the square root of x, okay? And I'm just going to add 3 to both sides of the equation, okay? And I'm going to actually erase all of these kind of middle steps here. And let me get rid of this. And let me drag this up here so we can go back to those restrictions. And I want to think about this with you in terms of why we don't need this plus or minus 1. We just need the positive. If y is strictly greater than 3, well, I have a 3 right here, okay? The x here is underneath the square root symbol. So I know it has to be, in this case, because it's in the denominator, something that is greater than 0, which is given to us by that restriction right there, right? It can't be 0 because square root of 0 is 0, and dividing by 0 is undefined. It has to be something larger than that, okay? In the numerator, if this was negative, well, now what would happen is I'd have a negative over a positive, okay? And then I'm adding 3 to that. That's going to be less than 3. And here I know that y needs to specifically be greater than 3, okay? So I know that this guy right here has to be a positive 1. So I can get rid of this. I don't need a plus or minus there. This is going to be the only case that I need to think about. Now, the only other thing I would do here is I would replace this with my f inverse of x, okay? And I probably should make that a little bit cleaner. And then over here, what I would do is I would rationalize the denominator first. Let me put this over here. So I would multiply this by the square root of x over the square root of x. Let me just kind of drag this down here. So f inverse of x is equal to, I'm going to have the square root of x over x, and then plus 3, okay? And I'm just going to list here that I have x is greater than 0. And you can come down here. And if you want, you can even get a common denominator. I think that's how the answer is given in our test. So f inverse of x is equal to, I would multiply this by x over x. So my final answer here would be the square root of x plus 3x over the common denominator of x. And again, we have x is greater than 0. Okay, so this guy right here is going to be your inverse. And again, if you wanted to see this graphically, you could play around with this with an online graphing calculator like Desmos, or you can use your TI-83 if you want. This is the line y equals x, so this is y equals x. This is our domain restricted function, so f of x is equal to 1 over x minus 3, quantity squared, where x is greater than 3. And then this guy right here, this guy in purple, I guess, this is the inverse. So f inverse of x, we'll go ahead and write that as the square root of x plus, let's go ahead and say 3x over, I'll say x, where x is greater than 0. Okay, so you can see that guy right there. It's a reflection across the line y equals x. Again, if I go back to that point, which is 4, 1, I reflect it across the line y equals x, and I get 1, 4. Okay, so you can see those guys are inverses of each other graphically.